Hello. We learned in the last lecture we learned the clustered standard error method. So in this chapter, the main theme was how to handle panel data, how to exploit the panel data structure, information from the panel data structure using two dimensions, entity dimension and time dimension. And the idea was simple. We have to think of state fixed effect, like entity fixed effect, which captures the entity specific unobserved characteristics that are constant over time. So the fixed effects, entity specific fixed effects, control for the unobserved omitted variables as long as they are time constant. And at the same time, using like symmetrically, you may consider time specific fixed effects at the same time. So you can include two fixed effects into the panel data model. So because panel data has two dimensions, you can handle two fixed effects, and then it can control for a lot of unobserved omitted variable biases. So omitted variable biases that arise from the unobserved variables uh, are observed into these fixed effects as long as either they are time constant or entity constant. And when you calculate the standard error, it is usually recommended to use the clustered standard error. Clustered standard error considers three main main features of panel data, like state error term is uncorrelated with any other state's error term. My son is here. Say hello here. Come and say hello. Come say hello. Okay, go sleep. Bye. Um, and second, within a state, there can be correlation across time. So the previous year's outcome may be correlated with the following year and in the future. So the correlation should be considered. And third, the heteroscedasticity may happen across states. Some state may have larger standard deviation, like larger errors, larger noises than other states. So considering three at the same time is the clustered standard error. And implementation is pretty simple. Just remember this option. So remember xt first. So in implementation, I am going to demonstrate the implementation soon. First, in on Stata, you have to set up, like you have to command the panel data setup xt set so that Stata understands the data has two dimensions. You have to specify what is the entity and what is the time. And second, when you use the command, you have to use xt-regress. So xt-regress is the panel data regression specific command. And option FE stands for fixed effects. Of course, to use this option, you have to use xt-regress. And also, I recommend you to use clustered standard error option. So like this. Okay, so this is a basic introduction to panel data model. And let's think more about the example, the drunk driving and tax rates and traffic death. You may read what's going on in the data. I'm not an expert in there, and I am like without understanding these facts, it's still you can understand what's going on from the results. So I will skip those parts. I did not read it either. So in the end, in the previous example, we considered only two variables: traffic fatalities by state by year and beer tax. But like we did in the regression model, there you may include more control variables. Even if some omitted variable bias can be fixed by the fixed effects, but still you may want to include control variables because there may be omitted variable bias that are not time constant or not entity constant. So these assumptions may not hold in some cases. So we add other than these two key variables, traffic fatality and tax on a case of beer, we include minimum legal drinking age, which may change over time and also change across states, and minimum sentencing laws for the first driving with influence violation, mandatory jail. Oh yeah, wow, it's quite strict. A mandatory community service, and what's the minimum? What's the minimum for DUI, and vehicle miles per driver? How experienced the on average driver is, or the I think it's about density. So how much miles driver drives like in a year, and other economic data like per capita income and like unemployment rate maybe, and inflation. They may be also related to traffic fatality rate in some sense, right? So using these controls, how can we implement? And still, so even if we included these control variables, still you have to understand that there are unobserved characteristics. Like first type of the unobserved characteristics are constant over time. So culture of drinking and driving, quality of roads, and vintage of autos on the road. So these kind of unobserved characteristics are specific to a state, and it does not they do not change over time. Even if they change, it must be pretty little relative to the other variables and other variables we are interested in. So these will be handled. These variables can be handled by the state fixed effects. And on the other hand, there may be some omitted variables that are specific to a certain time or year, but constant across states. It changes at the same time across all states. Something like improvements in auto safety over time, like maybe technologically or national law may require more safety options, for example, or changing national attitudes toward drunk driving. So I don't know, but like if there was any national campaign or nationally known accidents or some like say movies, shows that is related to drunk driving, maybe there may be some effect nationally at the same time across all the states. In these kind of unobserved characteristics, time-specific characteristics are handled by the time-fixed effects. So in the end, in our regression, we will include all these variables, control variables, as usual, and they are observed. These are observed, and also we include state-fixed effects and time-fixed effects. But remember, state-fixed effects can be implemented by using FE option, but time-fixed effects requires like your own like manual handling, like including dummy variables for t-1 years. So then as a result, we have this regression table. So dependent variable is always traffic fatality rate, and like it's 2 pages, and so then the fixed effects are not reported. Usually they are not reported, but they are like just there is an additional line that says whether you control for that or not. So state effects, no, yes, yes, yes. So the first one does not use state fixed effects, but all the other models include state fixed effects. Time fixed effects, no, no, yes, 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 yes. So the first two models do not have time fixed effects, but the others have the fixed effects. So simply the first model does not use any panel data structure. Second model uses, but only in the state dimension. And from the third to the last, it fully uses two-dimensional fixed effects. And cluster standard errors, yes, here the first one does not use the cluster standard error because it does not utilize panel data structure. Years are the same, and the last one is a little bit special regression model using only 2 years. So let's think about the first three because they differ in their usage of fixed effects. And from the fourth and later, the difference is about in the control variables. Some control variables are included and other and some not. So it shows what is the effect of the control variables. What is the omitted variable bias if you do not include some of the control variables? And let's look at the first row because we are interested only in this guy. By the way, I don't know what this means. It must be a typo. I don't know where it is from. Anyhow, ignore this. Interestingly, the first regression has positive coefficient on beer tax, and all the others have negative, even if they are not that significant. So this is significant, but the other guys are. This is significant because you can tell whether it is significant or not by reading the confidence interval. The first confidence interval only has positive numbers, so it is significant. It does not. It is surely positive, so significant. It is surely negative, so significant. But this starts from negative number, but ends at a positive number, so it can be negative or positive, so it's not significant. No, it includes 0, so it's not, but it's significant. And what is interesting here is the change of the sign. So, and I explained why. We already learned the same thing, and there is a huge change from here to here. So, including state-specific effect is very important. So, there are many like unobserved characteristics that are specific to the state, but constant over time. They are important. But from number 2 to number 3, the change is not big. So which means the difference between these two models is the time fixed effects. So year fixed effects is less important because the change is not big. But between 3 and 4, the difference is the inclusion of control variables. The control variable causes quite a bit of difference again. So the control variables are doing something, they are important. And difference between number 4 and number 5 is the economic variables, inclusion of economic variables, and they are also very different. So economic variables are very important. Interestingly, they are very significant. So unemployment rate is significant, and real income per capita is also very significant. So as you can see, number 3 and number 5 are not much different, which means these control variables are less important. But there is a larger difference between 4 and 5, whose difference is in these economic variables, implying that there is a big difference in the effect. So economic variables are more important control variables, and they cause a bigger omitted variable bias. Maybe because the variable of interest is beer tax, which is related to the economy. So unemployment rate or real income may be more correlated with beer tax than drinking age or minimum sentencing, something like that. So this is how we interpret. And number model 6 is the difference between model 6 and model 5, model 4. Model 4 and 6 are different how we handle drinking age. So model 4 includes 3 dummy variables, drinking age at 18, 19, or 20, but you may include this as another variable, like, so 18 is a number, 19 is another number, 20 is another number. So additional increment in the drinking age increases the fatality by 0. So barely no effect. So and the final one only uses 2 years. It's quite different. Anyhow, the point here is fixed effects are important. You need to control for the fixed effects, but you don't need to report all of them unless there is a special reason to show them. Usually they are reported in this way. You just tell the reader that you are using the fixed effects. So there is no state-specific or year-specific unobserved characteristics causing omitted variable bias. And also you may consider some F statistics. I will skip this. Okay, it's exactly the same thing which I explained earlier. It's more argued in a more rigorous way. Which I will skip. Okay, so in the next video, so let's think about the main results. Exactly the same thing. The peer text sign changes when fixed effects are included, and time effects are significant but does not have much impact, and blah 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 blah. You may read it. So economic variables are important. Peer text seems to be negative, but it is not statistically significant. Okay, that's this is the end of this chapter. I will do homework 5. Okay, thank you for watching. I will see you later.